Okay, got a big to-do in the shop tonight, folks. We are back to working on our 2x72 grinder. My motor came in. All I'm waiting on now is the belts, and it's irritating. They were in Rochester, New York, so about 20 hours ago now. And of course, they couldn't get it here for today. Rochester is about, it's close to 3 hours away from here. But I guess it is what it is. So, this is a 230/460 volt motor, 3-phase, 2 horsepower. I bought this motor from Compressor Source out of Nebraska, and I see it as a made in China motor. Naturally, why wouldn't it be? I got this motor a little over 200 bucks. I read some pretty good reviews on them. I guess they're very smooth. That's what I'm looking for. And this is a inverter rated motor, so that is very important if you're using a phase or a VFD like I am, because you do have voltage spikes, stuff like that. So it is something to be aware of. This is also a sealed motor with a fan for cooling. The reason being, I could get an open face motor where you see the cage open for cooling, but what happens is that all the dust from the grinding and stuff like that is just no good at all. And we cannot run this motor without setting up our electrical properly. So these motors often come with different ways of wiring it. So this is a dual voltage motor. It's either 230, which we should be putting out 220 volts out of that frequency drive. You're allowed 10% up, 10% down. We would be safe down to 210 volts for this to operate properly, which would make it rated for like a 208 volt motor. We're definitely going to want to watch all that. As our hertz drops, the voltage, of course, is different needs, things like that. So what I was looking for, I wanted an enclosed motor. Like I said, that's so the dust from the grinding doesn't get into the windings, eat it up. This is actually a very heavily built motor. I'm actually really happy about that. So our frame spec, it's a 56 HC frame. 3-phase continuous duty, which is important. This is also, this is kind of important, good to know. Usable at 60 hertz, 208 volts, 5.58 amps. That's actually real good to know. The VFD that I have is actually good up for, well, it's good up to a 3-horse motor, 12 amp. So even at the highest amp rating this thing has is 5.8 amps, so we will be fine there. We're going to wire this right up on the bench. All the finesse in the world right there. Just comes down to whacking shit with a screwdriver. Okay. Now this is not a proper, it's not the proper box connector for SJO cord, but it'll work fine for what we're doing. I couldn't find what I was looking for today at all at the local Blows for the for box connectors, so we're just going to make do with what we have. I don't worry about using this because there aren't any sharp edges inside of this connector itself. So it really shouldn't give us any issues that way. Now go down around that wire nice and tight. Alright, so let's see what we have to wire this thing. So, blue and brown, T1 and T7, so there's T1. It's T7. That's going to go to line 1. use red as our line 1. Doesn't really matter because this 3-phase motors, if you do not have a reversible frequency drive, like this is, all you have to do is swap one of the legs of the 3-phase to reverse the rotation on the motor. And you're dealing with a stranded fine wire like this, make sure, check underneath that wire nut when you're done, make sure you don't have any strands sticking out. I have had that before. And go to reach in when it's live and get yourself a little zap. So we got white T2 to red T8. White T2, red T8. Double and triple check yourself when you're wiring this stuff up. One wire out of place and you can fry a brand new motor real fast. Don't ask me how I know. All right. Now for our next, we are going to have orange T3 and yellow and black T9. Cool. It's a lot easier to wire these things up on the bench before you put it on. You can see everything better. Looking at the schematics, it's a very, very simple schematic. Nothing too complicated, which is good. So, what do we have? Up here. So the top part up here looks like we have for sensor inputs, things like that, if we ever wanted to put a tack on it. So we can run by RPMs, not strictly by Hertz. We are not using it in this manner. What we're interested in is down here. This is where our power comes in. That's where our power leaves. But I wish we had regular knockouts for this. Now here's the deal with this one, folks. This is not a NEMA, this is like a NEMA 1 enclosure. I would much prefer a NEMA 4, but this thing was under $100. We have our heat sink on the back. So we're going to help keep it cool. We have a little tiny computer fan on the bottom. I'm sorry about my lighting, I know it's garbage. So what we're going to want to do with this, the dust from the grinding and just in the forge in general will eat this thing alive. So we have some really good filter media that we're going to wrap this thing with once we have it wired up and hung on the wall. So that's that. Oh, they go in surprisingly well. I gotta be careful of this enclosure because after all, it is just plastic. It would be extremely easy to really goof it up. Loosen this up a little bit. There we go. Let's see if we can get this on here straight. Crooked electrical boxes are one of my pet peeves. I know you would think looking around this place, this guy can't, there's no way in hell this guy has any pet peeves about anything like that that could be disorganized or messy, but that is just one of those things. Does not take long to take a tube and level out and throw it on something to see if you came out level or not. There we go. Now let's make sure the camera's even on. I've known to do that before. Okay, let's see here. Kind of excited for this, guys. Let's just pop that right off, make it a little bit easier. Now this is kind of cheesy. Why the frig you wouldn't put... You'd think they'd have just some normal run-of-the-mill box connections in this thing. Instead, you have to sit here and cut this out. It's kind of dumb. You have to do the same thing on this side. But I guess you get what you get. You get what you get, and you get what you pay for. I'm just going to twist these up a little bit, make it a little easier to get it in here. It'd be really cool. That is so freaking cheesy. But it's what we have to work with, so we're going to work with it. Boy, they do not give you a lot of room in here, folks. This ought to be interesting. Who's ready for a swearing, screaming fit? Who's with me? Who is with me? Dirty, filthy bastard, where did I put the damn screwdriver? Holy freaking hell. Wow. I'm doing this more and more every video. I'm spending half of my time when I should be running the camera. I'm spending half of my time looking for my damn screwdriver. Then sitting here complaining that I can't find my damn screwdriver. The same screwdriver that I just had right there fell on the floor. How about that? I knew it was here somewhere. Okay. Can already see where I'm going to want to put a disconnect switch right here at this box. So we'll definitely be doing that. I don't have one at the moment, so we will just do what we can do here. Now I'm taking a chance on the ground wire. In the directions, it shows that is a ground lug, but it's written in friggin' Chinese in here. Everything else is in English, but this guy's in Chinese. Thanks a lot, translators. If I start saying evil things about the Chinese and small hands and things like that, ignore me. Don't report the video. It's not hate speech, it's just merely an observation. Folks, be careful when you are tightening down lugs on stuff like this. They are just into plastic. You need your connections nice and tight, but you don't need them so tight that you're breaking that plastic off. And the other thing you really want to watch when you're doing stuff like this, I mentioned it earlier, when you're doing stranded wire, make sure none of those strands get worked off of there, because it would really suck. It would really suck if you happen to short something out, especially in this application where you're actually going phase to phase on something. It's just not a good program to follow. Now let's try this a different way. Let's bury it 6 friggin' inches into the back. Let's just do that, huh? Let's put it in a spot that no normal person on this friggin' earth can get their hands into. I mean, yeah, that's great. We'll make those stupid Americans figure something out. Come on. Holy shit, we got it. Give her a good tug, make sure she can't come out of there. Now that worked well. I know this camera angle kind of sucks a little bit, but I've got to program this thing. So you got to love it. So basically what I'm doing here is I program every inverter VFD is going to be a little bit different depending on the manufacturer. So it's really kind of hard to give a primer on exactly what we're doing here, because if you buy a different one, it's going to be slightly different. Some of them are plug and play if you get them for the specific motor and application you're running. This one is a kind of a Swiss Army knife inverter, so it has a whole lot of parameters. Let's see, how many are there? Yeah, it looks like there's 127 parameters, but there's not terribly too many that we have to worry about. So to get into this, I'm going to hit the programming menu. So right now my maximum voltage is going to be 220. Let's see. Okay, go to parameter 1. Reference frequency, we're going to be going to 60 hertz. Parameter 2, intermediate voltage. We'll leave that alone. It's going to be right in the intermediate voltage is going to be the center. So parameter 3. Intermediate frequency is going to be 30. This is kind of set up for a European. Hey, parameter 4, minimum voltage. We're good there. Minimum frequency, maximum operating. We're going to go to 6. I want to turn that down to 60. Not a bad idea as you're going through these. It probably wouldn't be a bad idea to write this down. Now we're going to go up to 10. And now, like I said, on this, it's going to be different what you have. This talks about our working frequency source. I could either use the keyboard, the up and down arrows, or I can use the potentiometer, which is this dial right here. I'm going to use the potentiometer. And the default setting to that is already on there. We go to 11. That is our stop start control source. It's set default as 0. I'm going to keep it there. Now this is one of those things where you can open up the top here on this particular model and you can put an external start stop on there. We're not using that at this point. Sometime I would like to. I am going to get a 220 volt switch for this thing, just so I can turn it off right here, not just at the panel box. Stopping modes. I want to make sure that's where it's at. Okay. So stopping mode, I want a deceleration stop, so it kind of brings it down gently. I tell you what, I am so excited about this. We are so close to just running this thing. All I'm lacking is some belts. That's all I need, and I have some ordered, and they should be here Monday. So that makes me excited. Now there may be some alignment issues that we'll have to contend with or adjust here and there. I did the best I could with straight edges, but sometimes you just really don't know until you put something on it and see where it's going to go. I was going to paint this part. I kind of like it the way it is. I really do. But what I like, and I'm super excited about, is that the three-phase portion of this came together. Of course, time will tell how everything works, how long it works, things like that. Obviously, the enclosure on this VFD is not, it really isn't good for this application, so I'm definitely going to have to do some things to protect the innards of that VFD drive from the metal dust and things like that. That's one reason I put it up here on the wall, but it's still going to get it. There's a little fan under here that's going to suck everything up through. It'll coat the inside and it will ruin that thing really fast. And if that thing gets ruined, there's a good chance that it could take the motor out with it with goofy voltages, things like that. A lot of times that's how it happens. But yeah, that's really cool. Just hit the run button, crank it up, watch it go. Hear that whistle? You know, it's fairly quiet too for what it is. It may sound loud in the microphone, but for me sitting here right next to it, it's actually very quiet. It shouldn't be though. It shouldn't be as quiet when we get a belt on there. But, you know, I could have I could have gone the single phase motor and then did a couple of pulleys, things like that, the stepper pulleys, and I almost did that. Excuse me. Super late. But I probably could have done that and gotten away with it, but I really like the controllability of something like this. I think it'll make a big difference, and like I said, I can adjust it up and down easy enough as I'm grinding. Now that's something too over time that I can get different things for this. I can actually get a whip for this little control panel on the front here, mount this in an entirely different spot, say go on the other side of this wall where there's no dust, and have that patch into here, I could do that. That is one option. Chances are, though, it's probably going to live here forever until it burns out and I have to get another one. But that's where it's going to go. Now, I'm going to have to bolt this down to the floor. You guys know the floor in here. It's just not even. I've said that over who knows how many videos. But we're definitely going to have to get that anchored down so we don't get any vibration. I'm just cool. I want to use it right now. I want to test this out. You guys haven't seen a lot of videos this week because I've been on call for one and I've been getting called out. But I've also been forging draw knives in here all week, and I have a few ready for the grinder already. And just to test this thing out, we're going to have to make some jigs and things like that for it. So anyway, I am just yakking on. I'm really excited about this. This is such a big piece of the puzzle for us and what we're doing here and what we want to do. This is something that I notice a lot of blacksmiths, a lot of knife makers, things like that. It takes them years sometimes to get stuff like this in their shop, and they do everything the hard way. And I guess I'm really no different. It's been more a matter of waiting to get the time to do it and get the funds. But I've had the philosophy since I've started this journey and what I've wanted to do with it that I don't want to be putting anything out really until I'm kind of set up to do it right. And by right, I'm talking consistency. I'm talking getting things in a timely manner. And for me, it's always been, in 6 more months. And 6 more months. Well, we're now finally looking at that time to where that time is kind of upon us. I'm going to hammer things out on the anvil as long as I can. We are going to be building a forging press this coming week. I'm going to be going after the I-beam. I work with a young guy who just bought a plasma cutter, and he's dying to try it out. So he's going to go with me, and we're going to get that thing in the shop where I work, and we're going to get it cut to the lengths we need to make our forging press. And then from there on out, it's going to be just saving up for the hydraulic parts. I thought I had some rams here that would work, but they're too small. So we're going to be getting some 5-inch rams. There's going to be 2 of them, probably a 12-inch stroke. And but you guys will see when we get to that. One project at a time, I guess. So anyway, hope you guys enjoyed this one. And sorry I yak too much. Sorry I swear too much, but that's who I am, folks. It's just the way she is. So have a good one. I'll catch you on the next one.